Hey everybody, this is Brad Dyke reaching out to you, and I have been surprised. The reason why I'm doing this video is because I've kind of discovered that you guys really want to know those super fine details about what it takes to get into a data center environment kind of setup and kind of tweak out and all the little details that even me vacuuming and cleaning apparently is something you guys really have interest in. So I said, okay, well, that's fair. I get that. I can do this. So I decided to add make this instead of a two-part process to make it into a three-part process. So what we're going to talk about in this video is what's in between, as in when you tear it all down and when you start populating the racks for the start. So there is actually a sizable amount of work that is done in between them, and that is, of course, in this particular case, the preparation of the rack itself and how you want to make sure that it's put together. So that's what we're going to talk about. So the very first thing we're going to talk about here is the nature of the rack itself. I mean, this is a true standard industry 42U rack, and as you can see, it's clearly indicated by its make and model and configuration. This is a standard industry open format version, and as soon as it can focus a little bit better, I think we'll be in pretty good shape. Focus. Come on, you can do it. There you go. And of course, I've got a PDU here, which I got from Harbor Freight, which works just fine, by the way. And it goes down to here to the side. Over here, I also have open spacer areas at which I purposefully remove the outer panels because if you have learned anything about my videos, you learn that convection is the key to keeping your small data centers and labs cool. Convection is basically the natural power of heating and cooling, not necessarily what you can push through a heat sink or through an HVAC system. And then, of course, down here you can see the actual remnants of the wire rack mounts and so on. And actually, if you look right here, you're going to see a red, green, blue belt LED. Now, let me turn this on for you real quick so you know what it looks like. And I do this because it's easier for your lab if you don't use, the big, powerful, bright lights, which you have here. And these are LED lights as well. But in here, I have it set up in such a way so that I can use low yield light output for what I want. And I can do any color I want, of course, but I usually just use blue, something along that pathway. And then, of course, as you can see, cable cleanup. And there's quite a bit on the floor here where you can see that I've been pretty much gutting my lab environment. And it is a major undertaking. It really is. And down here, of course, my 15 amp my power distribution panels here from the wall will plug into these PDUs, each 15 amp each. So that's 30 amps I have availability, which is not really truly 30 amps. It's more closer to about 25 amps. And then, of course, I have down here my standard plug-ups for connectivity. Now, this rack is fully mobile, and I do always recommend that you use casters and use what's called a secure base. A secure base is important because a secure base actually gives you a true bottom on a rack. And no, I'm sorry. Anyone who tells you that having an open base is going to be great for air convection, they're wrong. Because the underbay of a server rack enclosure is pure metal. So you're going to create this effect no matter what. So put a base underneath it just as added support. Plus, it actually acts as a platforming effect for the first couple of heavy-duty pieces of equipment, which you always want to put on the bottom of your rack. And as you notice, I still have plenty of air ventilation and effect that's in the play, but this is the right way to do it. Now, something else that many of us will skip, and I don't recommend this, but they do it, and I shouldn't. And that is this guy right here. This guy is a grounding strip mounting point. And what happens basically is you will take your grounding wire, which is this guy right here, and this grounding wire will come from a source. And in this case, the grounding wire goes to this particular circuit here, but these are all on the same ground. So I can share that ground. And then this second wire here, as you can see, goes to the second rack from the first rack. And this is how I can provide myself a true central ground. And I have a lot of central grounds in my lab itself because I just work with too much electronics not to. But with that being said, number one is pretty much set now. It's in good shape, and it's ready to be prepped for the first rounds of what I intend to put in here. And my plan right now is to do what's called parse and pair. Parse and pair basically means that in one rack, which will contain the master switch and so on, will have what's called the operational enterprise model. In other words, I'm going to run a HANA model, and I'm going to run an LDAP model, and that would be a constitution of about somewhere between 4 to 6 servers for HANA and probably 2 to 3 servers for LDAP. That's a good thing because that basically allows you to be able to produce the ability of platforming. And then over here on this rack, I'll have my son's lab, and I'll have my NAS head, which will be actually a true NAS head, the one that's going to upgrade from the old Isilon platform there to the new DX720. The Dell R720. And with that being the case, this rack is going to be building up auxiliary side, which will probably just do the housing of 1 to 2 to 3 server roles. And so that means basically, in a nutshell, I'll be able to turn around and produce the ability of having both a home lab to do like Plex store testing or something like that, as well as my enterprise lab, which I can use in regards to the capacity of working with, for instance, my new job is I'm working in DevOps, and transforming operations into a developed contiguous style operations environment, and that takes a lot of work. So as you can see here, I'm getting ready to tear down the second rack, and I'm going to be basically showing you the values of what these are and how they will actually add up to being something of benefit. I know it still looks a little messy, but I thought this is a nice comparison. Here's what you got here, and here's what you got over here. And I'll have to do this in stages because obviously I'm moving the camera around, and I can't move camera and pull wiring out at the same time. So as we go through this, I'll slowly start to stage things out of here, and you'll see why. Now, this little guy here is called a half pipe or a half set shelf, and it's basically 1/3 the strength of a half point shelf, or it would be the equivalency of a full quarter shelf. And full quarter shelf looks like this. It's a big shelf, as you can see, and it's capable of holding a lot of weight. It uses a lot of the clamp seats for holding its base, and it's got a lot of surface area. Now this guy doesn't, but what it has is it has perforated panel sections, which allow you to zip tie and secure actual connection points. And these guys are for the eSATA arrays. So they're going to come out of this, and this cable manager will come out once I clear the wire as well to show you the back sectional of this rack. So with that being said, you're going to see some of this wire go missing as I get this prepped for you. And then I'll show you what's going to be one of the most important initial things that you need to consider, and that is how you're going to do your remote keyboard and video and mouse. So give me just a minute here, and I'll be right back. Okay, so as you can see here, I've taken the 2 cable mounts out, and now we have basically a nice, very clear, exposed frame, and I'm going to talk to that frame in just a second. But here's a problem that I don't want many of you to make mistake-wise. If you look at this, you'll see that even though I hold this up and down, this is bent. And this is the problem you get sometimes when you get old standardized or quarter size or even third size style shelving, is that they have a great value, but they also lose a lot of their integrity. And that tells you that the smaller the shelf and less rigid in frame structure, you see how this frame structure is here? And the least of it is because it's really only here in the corner and on the front. Everything else is just flat metal. Unlike a Universal, which has more capacity and has more bends and corrugation effects, which allows that metal to be a lot stronger. That's why when you're looking at these kind of shelves, they have a lot more strength to them because they have that larger bent frame structure. Now, something else to notice about this particular rack versus my other rack is that if you look at my first rack here, which is, as we can see, independent, This is called a housing set with a management capable frame bent in to the actual frame of the actual unit. So, in other words, you can run power cables, you can run network cables up through the inside of this. Over here on this rack, you have a clear cut access point from back to front to the actual mounting points. This is the kind of rack that is excellent for direct mounting. You have a little bit of corrugated support here, but the corrugation effect, that's what I was talking about, that shelving over there, is if you look here in the corrugation effect, it's a very strong piece of metal because it's bent in 1, 2, 3 locations. Not to mention that it also has these hole mounts, which means dealing with strip screws is no longer a problem. You just simply replace the nut bolt and you're good to go. Now, this also has a recessive effect, and this is the area where you can place your power distribution surge strips. In this case, this is my older generational style surge strips, which are on both sides here, the gray ones, versus my black ones, which are over here. They're a little larger, and because they're a little larger and a little bit more bulkier, direct access mounting to the back screw mounts is kind of a pain, unfortunately, because your screwdriver is not going to get that penetration in there because you only have this small amount of room to work in when you're dealing with your power strip being on the outer edge like this. But it still works, and these are two different classes of racks that are out there, and you can get them pretty cheap, about $50, $60, $100 a lot of times, because they are from the older generational enterprise environments, and they have real good depth to them. You can have any depth that you want with this particular style, and the same way with this one, except this is a slide track opposed to a bolt track. And with this, you just have to decide which one is going to be the better solution. Now, to be honest with you, this rack is actually my better rack. And even though I have at the very top, you can see I have air handlers, air movers up there. I don't use it. It hasn't been used in a few years. I've been so proficient in getting the convection effect in this particular rack design, which is called a Rightliner's rack, that I am able to really keep my hardware pretty cool for quite a while. Over here, the issue about this on my side is I have an open-ended panel section up here, which is okay. There's nothing wrong with that. But I also have a lot of subjugate style exposed metal. Now, this metal is not painted the same way as the Rightline enclosure painting was done. This is an anodized style paint job. It resists heat, which is really nice. This one, it's not so much. It really does hold on to the heat. And when you're in a lab by yourself in a small room, heat matters. And so I don't try to populate this one as much. Now, the next thing about this rack, the Rightline enclosure, which is a little bit nicer than this one, even though they're both 42Us, they are basically not the same beast. This case basically runs around $4,000 a piece, and this one is more of about $1,000. And you can tell by the nature of the metals and how it's coming together. They have a framed corrugated structure here, and this metal is not steel. This is a different kind of metal. It's more like a thicker tin, almost like kind of setup. It is not aluminum, which would have been a benefit because aluminum obviously is a good dissipator of heat. But this is steel. And, this is just such a rigid, stronger system. But, you can't really complain about what you get your hands on when you're working with this kind of stuff. But what I usually tell people is if they go out on the internet and they want to get themselves, a rack, definitely get a 24U or a 42U. Don't do anything smaller than a 24, 25. Because really the function is just not there. With the 25, you can put a keyboard and mouse and monitor on the top of it, and you can use that as the top of your KVM station. But as you can see here, this is 42U holds everything. Now, the next thing that I need to talk about, and this has usually been a surprisingly good response, I'm impressed, is basically my KVM extension cable and USB. So all of my gear runs through USB, and I do have an audio output here, but I have taped it down. That's up here at the top. If you want to look at it, you'll see the audio jack right there, But the key thing is, how do you and why should you basically KVM at range? And that means basically over here, my trusty old 15-year-old ViewSonic square monitor, isn't that terrible? But it's also kind of cool. Is just what it is. It's a really great setup, but it's getting a little old. But over here on the side, I have my USB hub breakout for my keyboard, mouse, and so on. My VGA output here, and it's going across the way over to here through a 16-foot two-pair wiring, which is basically gives me just a little over 30 feet of flexible length where I can run it against the back of the wall all the way to the back side and up to the base, and then it travels up to the side here and goes here. It also has a Cat 5 run cable as well, but we're not going to talk to that too much right now. By using these two paired cables, I can use what is known as track feed. And track feed is basically conduit that we put on the wall to contain and control the flow of the wiring to keep it, protected from insects, animals, and so on. And that goes down by underneath my HVAC tubes over there. I'll show that at a later time. But right here, as you can see, it's pretty cut and dry footprint that which we have here. And this is the core hub. And I use an OmniSwitch for my KVM, and it's got 8 functional ports. And the cabling down there has all the paired sets of cables that I'll have to, of course, clean up. And as I clean all that up and I prepare everything, I'll then first put in my KVM network. I'll bring this in, and right over there is a cable that's coiled up over there. Let me show you that. So here is the one standard split port. It has a large edge connector here, which goes on the back of the switch, and then it has 2 VGA outputs for 2 individual servers. Now, this is not really critical. You need to have a KVM environment? Do you have to have, always connect up a mouse and keyboard and so on and so on? The answer to that question is no. Is it good to have a small KVM on hand? Yes. And the reason why is because most of you are familiar with what we call x86 based systems. Now, in the old days, that wasn't the case. Most of us did our processes and setups and so on through what is known as a serial connection. Kind of a slow connection too, to boot. But the key thing was that we could simply connect up a 9-pin connector or a 25-pin connector, or even a serial RJ45 connection, plug it into the back, connect, start loading up, and configuring the hardware in such a way so that we could do what we want to do. And that is basically, get an old box up and running. I usually call those Sumfires and the old HP platforms and so on and so on. But over time, as the x86 based systems came on board, they came with video cards. And we started to learn a different way of configuring initially the outputs of our systems, and even eventually became more like a desktop interface. Well, as we're evolving, we're kind of remixing back into what we call the command line level and also the desktop level. We kind of like to use web front ends today for our graphical user interfaces, while we run our hardware as at a minimal state on basically what's called command prompt display. So why should you have a KVM in backup just in case? Well, the answer to that question is pretty simple. Well, a lot of the times, for instance, like a TrueNAS platform or a PFS Sense and so on, you can connect a KVM temporarily up to the unit as you build it for the first time. Same with Proxmox. They're all the same way. Plug up a mouse and keyboard, get everything configured and set, and then disconnect the keyboard, video, and mouse. Hence the reason why you don't need to have every device connected to a KVM setup, just to be able to do them as you need to go. A 4-port or an 8-port is overkill, in my opinion. But it is great to have them because a lot of times it never fails. You'll have more than one that you're working on. And so As my son was moving from window box to window box to window box, and he was testing and learning how to do stuff, he would just move the KVM ports down to the next server and do whatever he was going to do. Or he could pair up 2 or 3 of them and run all 3 at the same time and make comparable checks and so on. But at the end of the day, when he was done, he'd unplugged it all, and the machines just ran on IP-based interfaces and or web GUI interfaces, the graphical user interface. So with that being said, that's why I have a KVM on board. It's not fancy, and I don't use Cat5 based KVMs. There's a reason. It's actually good to be able to subjugate out your cabling. Cat5, Cat5e, Cat5.6, Cat7, and so on and so on and so on. Those are communication-based cables, and it's great to be able to quickly identify them when you're behind the rack and you've got 15 of these things in there. You immediately know what a KVM cable is when you see it, because that's the cable that's going to move around. And if you remember what I told you earlier in the discussion, you really want to make sure that your environment is very flexible over time. So you only have to do rebuilds on an occasion. And usually it's because you want to do something major. If your cabling is flexible, you don't ridge it down, you don't ziplock everything down, you can pull those cables back, you can put them back in a different configuration, and so on. And let me give you an example of that. As a great example, this is an example. I mean, I was running a 10 gig fiber pair for bandwidth test allocations, and here's my fiber optic cabling here. And then I had to pull this very gently out and make sure that you never, ever, 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 bend this wiring much, 30 degrees max, and never any tighter, never, ever, ever 90 degrees. But I took that out for a very easy and very manageable and very flexible copper GBIC 10 gigabit interface, and was able to stress test these together fairly easy. And of course, in the background, I've also got all my SASs and my mini SASs and all my other kind of cables, which out here, as you can see, there are so many of them. I can just pull and redo these racks just as efficiently as possible. I mean, it's just not difficult to do, when you look at this. And the nice thing about this is that if you're doing your prep for your racks, you buy a brand new rack, let's say, right? And you've cleaned it up and you've got your principles in place, make sure that when you choose to route your cables, that you understand what you're routing that least needs to be handled. Power cables are a great example of that. Put them strategically through the rack as you see fit. And by doing that, you're going to be able to accomplish a lot. And the way you'll be able to accomplish that is basically by going in and having yourself the ability to have those cables which you're not going to really ever move again, but you have all the other types of cables at which you will. And keeping them subjugated and quickly identifying them. For instance, I mean, the SAS cable is unique because it's got that special interface on the front. And a GBIC is unique because it has the black pullers on them. And your KVM cables are thicker and they have got a little bit more continuity to their flexing, so you know what they are. Obviously, fiber is either mint green or yellow, depending on the type of connectivity you have. And this gives you the ability to really scale. And by scaling, I mean you're going to give you the ability of being able to just quickly flip things over and over and over, but you're not necessarily deconstructing your rack in the process. So that's something that's really valuable. But one thing you also might want to notice here, let me show you, is if you remember my previous videos, I talked about the C-clamp style screw-ons, which are kind of loose, right? And then I told you about the weight load button ends, these right here, which actually lock into the actual hole and become rigid, very strong. So as you look here, I've got these, all throughout, and up in the front section here too. I've got them all over here as well, based on what I need. So with that being the case, the strength of this metal and the rigidity, in other words, the flexibility of this metal, is very important because things give. And I've seen racks bend, right here on the edge, and they bend. They kind of curve inwards because it's just not a solid metal. So it depends on what you put in and how you want to plan this out. So take the time, use a wrench somewhere on your rack, see what kind of give your rack has. And as you can see here, I've got holes in this one, which they can be used. I just choose not to use them because if I do, they'll, I have to start dealing with threading and so on and so on, and that gets messy. I'd rather like the C-clamp strategy better, and this allows me to be able to do that pretty easily. So with that being done, hang on here a second. The next thing that's important, believe it or not, is to police the base. Get your vacuum cleaner out. You're going to have cut zip ties. You're going to have dropped C-clamps. You're going to have dropped pressure clamps, screws like you wouldn't believe. Everything is going to be at the bottom of your rack from the last build you did. And it's important that you have a completely clean floor, because I guarantee you that when you put your stuff back into the rack, it's going to get particulated again. And your rack's not going to travel very well on the ground if you have casters, which I strongly recommend that you have casters on your racks. And then use edge locks or some type of way of locking down the actual casters when you're not using them. Caster locks are not the best. Usually what I use is a barrier at the front of my racks, and it's a special rug I have. It's designed to do that. So I just pull the rug out. I can move my racks around. I put the rug back in. Can't move at all. So that's an important detail. Yeah, it does really matter if you take the time to clean up as you're going forward, then the entire environment, including your overall lab. I mean, I've wiped out my lab doing this. I knew I would. It's going to be a chore. It's going to take at least 8 to 10 hours to get everything back into good shape. But this is something I wanted to do. This might be my last time I do it. If I design it well enough, it might be the last time I do this. I mean, all I do now is just put in new shit stuff and take out old stuff and things like that. But the rack rebuild will no longer be the traditional OpEx or CapEx style deployment. It will be more of a DevOps design implementation. So I can do a little bit more development on the application side or the API side, opposed to just playing with hardware. And yes, that's where your world is going. You're going to be merging those two environments. So I'm going to stop right now. I hope this roughly 30 minutes or so of video is valuable. It's a interlude pause between part one, which I've already posted up on the group. If you guys like this, please like it. If you don't like it, I'm sorry. I am trying, but this is something I try to do for people who just can't and don't have the resources to learn. So that hopefully you guys will be able to do some really cool and fun things yourselves. But with that being said, this is Brad Dyke. I'm going to sign off here and let you go. Please be safe and have a great weekend. Bye bye.